Hello everyone and welcome. Today we'll talk about law 3 of the theory of indices we've been discussing so far. The law 1 and law 2 have been discussed in previous videos. Here, the law 3 say we are going to investigate the case whereby we have a all to the power of m power. But what if everything is raised to a power? Let's say for example, suppose that we have a all to the third power. But what then we raise this to the second power? But but then we can evaluate this easily. Here, this is how. Since you are raised to the power of 2, this a to the third power is raised to the power of 2. We're going to treat this as one single quantity, which it is really. So this will be a to the third power times a to the third power again, because it is a to the third power all raised to the power of 2, and by indices we are going to multiply by itself twice. Now this will be equal to a to the power of 6 using the law we discussed. And then we will observe that 6 we can write this as a to the power of 3 times 2. So it seems that instead of going through the process of writing a to the third power twice, we can simply use 3 to multiply 2. Let's see for a to the fifth power, all to the power of 3. All to the power of 3. This is a to the fifth power multiplied by a to the fifth power and times a to the fifth power by the law of indices, and this is equal to a to the 15th power, because I'm going to add all the power 5 plus 5 plus 5. Now this as well is equal to a to the 5 times 3, which is which shows us that instead of going through this process of having to multiply them and adding, we can just use 5 to multiply 3. And we're going to verify this here. And notice here that if we raise a to the m power and multiply it n times, it means that a to the m, we have to multiply a to the m, multiply a to the m. So this whole thing equals, and this process will go further. It will go further n times, because it is raised to the power of n. Now this will equal a to the m's will be added. The m's will be added. How many times? How many m are here? There are m times as well. And sorry, n of them is here because we have n of the m's. So this is equals to a to the power of m times n, because m plus n, all n times is m times n. So we have proved this law that a to the m all to the power of n is equal to a to the m times n. Now, having said this, let's observe a special case now. Suppose then that instead of just a, we have b. Let's say we have ab all to the m. What then would this be? Well, if here if on this part here we have a b all to the power of 3, this will be ab multiplied by ab multiplied by ab, and then we will be having, we can notice that we can group the a one part, we can group a and group b, because in multiplication it doesn't really matter which order we take the multiplication. So this is a to the third power, b to the third power as well. So it seems that if we have this case whereby we have a multiplied by b to the third power, we can simply raise a to the third power multiplied by b to the third power. That is what this law is telling us. Now let us see if it is true. Now this ab to the m we call ab, no, this side should be in black as well. So black. So this will equal AB squared by AB squared by AB. And if we go further, AB factor will be here. And everything appear here m times. I don't want m times they appear. M times. So here we group the A's. And the B's. And then we observe that this is since A, B appear m times, A will appear m times and B will appear m times, because A, B both appear m times. So A will be m times, B will be m times. So this is A to the m and B to the m. So here we have derived this law that AB all to the power all to the m times is A to the m, B to the m. And then if we combine it with this law here, of course, if whenever we have something like A to the m, B to the n, and we have to raise it to the power of, let's say, p, this will be A to the mp multiplied by B to the np. So we have discussed the third interesting law of indices. Thank you for watching the video, and if you like my content, please subscribe to my channel for more. Thank you and have a nice day.